let's have a look at some questions. November 2016 question, right? Let's read this. The number of molecules of a certain drug in a bloodstream T hours after it has been taken is represented by the equation MT. Okay, so this MT is basically saying M is a function of T, or T is a function of M. X is a function of F. Okay, it's very similar to F of X. Okay, F of X represents the function of X. Okay, so in this case, we understand that we have a Y value and we substituting X values as input to get the corresponding Y values. So similarly, in this case, right, we have an equation represented by MT and whatever the equation is, right? So as you can see, the equation is represented in terms of T, just like how F of X would be represented in terms of X. So if it was F of X, we would have negative X cubed plus 3X squared plus 72X. The reason they're using T here is because simply T is time, right? T stands for time. Okay, but this just to get the conceptual understanding that it's the same thing as having X. Okay, this is a function of T. M is a function of T. That's why it's represented in terms of T. Now, the key thing is understanding what this formula gives you. So they tell you the number of molecules of a certain drug in the bloodstream after T hours is represented by this equation. So what does this equation give you specifically? This equation gives you the amount of blood, the amount of a certain drug, the amount of that certain drug or a medicine in the bloodstream after a certain amount of time. So just understanding it in English, what does it actually represent? So what it represents, that formula would tell you the amount of drug, the amount of a certain drug in the bloodstream. Okay, and that's why this is obviously variables. Okay, so when we substitute a certain amount, this we want to know how many drugs, how much drugs, or how much, what is the unit? Molecules, the molecules of a certain drug, how many molecules of this specific drug is in the bloodstream at 3 hours. We would substitute 3 into this equation and it would give us the amount of blood in the bloodstream. Okay, so I hope that makes sense. That's important to answering this question, is understanding what that represents. Okay, so 10.1. So let's look at this one. It says, determine the number of molecules of drug in the bloodstream 3 hours after the drug was taken. Okay, so this is a formula that tells us how much of a certain drug we have in the bloodstream after a certain amount of time. So what we can do is we can substitute it into that formula. So the formula is M is a function of T, that when we substitute a certain value of T, it's going to give us the amount of molecules. But now we want more specifically 3 hours as time. So we substitute 3 into the equation for T. Okay, so they didn't ask anything complicated. Okay, they just asked us to use that. Basically, it's telling us use that formula because they determine the amount of molecules of drug in the bloodstream. How do we get that? By this formula. This formula tells us the amount of drugs in a bloodstream, okay, after 3 hours. So that's why we just substitute 3 into that equation. And when we do this calculation, actually, we get an answer of 216 molecules. So the unit here is molecules because that's what the unit given is, right? The formula gives you what? Number of molecules. So your unit is number of molecules, which is 216 molecules. Let's look at the second question, right? Determine the rate. Okay, now this is important, right? We're looking at the word rate. Now this is where our calculus comes in. Determine the rate. Remember, how do we get rate? Immediately when you see this word, it should tell you first derivative, right? Rate of change, rate. So they say determine the rate at which the number of molecules of the drug in the bloodstream is changing exactly 2 hours after the drug was taken. Okay, so firstly, they want us, so now it's different. Like the first one is simple, just number of molecules. This formula gives us number of molecules, so we just use that formula and substitute 3. Now they want to know what is the rate at which the number of molecules were changing. So firstly, rate we understand to derive. So we need to find M prime. We need to find M prime, the first derivative. So we're just going to derive this guy, okay, exponent times coefficient, subtract 1 from the exponent. So negative 3t squared plus 6t plus 72. This would be the first derivative, the derived equation from this formula here. Okay, So M prime, that's it there. Now we've determined the formula which will give us the rate, because the screen is blurry. Okay, I get you. What I'm gonna do is I'm gonna throw a bit bigger and hope that makes it a bit better. Sorry, it's just the connection that I have right now is not the best. Okay, so I'm just trying to work with what I have. Hopefully the voice connection is still good. Okay, I'm gonna try and I'll draw in a bit of a bigger font so it's more visible, because I can't zoom in too much. Maybe I can zoom in a bit more as well. Okay, so here we go. The derived equation is, thank you for letting me know, by the way, negative 3t squared plus 6t plus 72. Okay, I hope that's better. That should be a bit better. Okay, that's the derived equation. Now, why did we derive it once more? Okay, because we want to get rate. Okay, they asked us to calculate the rate at which the number of molecules in the bloodstream is changing exactly 2 hours. So this formula gives us rate. It doesn't give us an actual answer for rate, because we need to substitute a value for t to get an actual value. And that's why they say exactly 2 hours after the drug was taken. So we have to substitute 2, okay, into the derived equation. We're finding the derived equation where 2 is the input. Minus 3, 2 squared plus 6 into 2 plus 72. Okay, and this gives us an answer of 72. Okay, so this gives us an answer of 72. Now, what is our units? Remember, it is a rate. Okay, so it's always going to be, a rate is always represented by dividing it by delta t. For those of you who do physics, you do remember this from rate of reactions, and many other times we've discussed it, right? Whenever we talk of the rate of change of something, it's always divided by delta t. So the rate of change of like velocity, or let me just think of another example. The rate of change of food, I don't know, whatever, right? Could be represented by food divided by delta t. Anything that you want to get the rate of change of, you divide by delta t. So in this case, right, let's just say we want to get the rate of change of, let's do the specific example, the rate of change of, what is it? What are we getting the rate of change of? The rate at which the number of molecules, so it's the rate of change of molecules. So it's molecules divided by delta T. So in this case, we'd have our unit as molecules per whatever our unit for time is. Okay, so it's molecules per, what is our unit for time? It's T hours after it's taken. So it's molecules per hour. That's what the rate would be measured in. Okay, because again, and the sound is good, perfect. Okay, and because again, our time unit is hour, so that's how we get that unit. So this would be 72 molecules per hour. Okay, so that's how we get the unit of rate. Hope that makes sense. Okay, once more, how did we get it? They wanted us to determine rate, so we derived it. The rate 2 hours after it was taken, so we substitute the value for 2 into the derived equation. Let's do 10.3. 10.3 says, how many hours after taking the drug will the rate? Okay, so here we have rate again. Okay, so what is rate? Rate is first derivative. Okay, how many hours after taking the drug will the rate at which the number of molecules in the drug stream of the drug in the bloodstream is changing or be changing be a maximum? Okay, so here we have maximum, and we remember what is maximum. Maximum is first derivative equated to 0. So they're asking us, when will the rate be at maximum? Okay, remember we discussed it here that sometimes they can ask this question: what is the maximum or minimum? Okay, because they would both use the same calculation. What is the maximum rate? So maximum is first derivative equated to 0. Rate is first derivative. So to get the maximum rate, you actually need to derive it once, derive it the second time, and equate it to 0. So it's the second derivative equated to 0. So between this and this, okay, we would need to find the second derivative and equate it to 0. So that's how you find the maximum rate. Essentially, that's what they're asking for. When will the rate be maximum? So now we need to find second derivative. Okay, so this would be negative 6t plus 6. That's the second derivative. But now we need to equate it to 0 because that's what maximum indicates to us. Whenever we want to find maximum, we need to derive it and equate it to 0. But now they ask us maximum rate, and rate is already this equation, right? Remember that this is what? This is the equation for rate. This is the equation for volume. No, sorry. This is the equation for molecules, the amount of molecules that we have at a particular time, right? This is a rate for, this is an equation for the rate at which that molecules are changing. And this is an equation for max rate. So how do you find maximum? You derive and equate to 0. What are we deriving? What do they want to find the maximum of? They want to find the maximum of the rate. So if you want to find the maximum of the rate, you need to take the rates equation and derive it and equate it to 0. So we derive the first derivative equation and equated it to 0. Okay, I hope that's making sense. Please, if you have any questions, stop me and ask. Okay, so in this case, negative 6t is equal to, so this is, we take the 6 over essentially, negative 6t is equal to negative 6, and t, we divide both sides by negative 6, t becomes 1. So the time at which the rate is maximum is 1. What's our unit? That would depend on the question. What unit are we working with for t? That would be hours. So the time at which the rate is a maximum would be 1 hour. Time at which the rate would be a maximum would be 1 hour. Okay, so I hope this is making sense so far. Please, again, stop me if you have any questions. Let's revise. That's the third question once more. Okay, let's revise all like really quickly, right? So 10.1, determine the number of molecules of the drug in the bloodstream 3 hours after the drug was taken. We have a formula that tells us, that calculates for us how many molecules are in the bloodstream after a certain amount of time. That's what the question told us. That's that formula. So we can simply take that formula and substitute the value of 3 hours, and we get the amount of molecules after 3 hours. The next one says determine the rate at which the number of molecules is changing 2 hours after the drug was taken. So the rate, we know if we want to calculate the rate at which something is changing, we can derive it once, and then that would give us an equation to calculate the rate. And they say 2 hours after the drug was taken. So that's why we substitute the value of 2. Then they say how many hours after the drug was taken will the rate at which the number of molecules of the drug in the bloodstream be a maximum. We can literally ignore all of this. They're just putting it for the sake of English. We can just say how many hours after taking the drug will the rate be a maximum. That would also make perfect sense. All right. So this is rate and maximums. Maximum rate for rate you derive once, for maximum you derive again, and for maximum you also equate to 0. So essentially you find the second derivative and equate it to 0. So the main thing here is that you want to find the second derivative and equate it to 0. Solve for the time where the second derivative is equated to 0. We solved for the time at which the second derivative is equal to 0, and that gave us 1 hour. So after 1 hour, the rate would be at a maximum. Okay, so how many hours after? 1 hour after. Okay, cool. Let's look at the next example. I hope that made sense. Okay, so this is where the calculus application can get kind of complicated. So I hope that this was simple enough. Okay, this first question was simple enough, right? It discussed the concepts that we did here directly. Okay, let's do a slightly more complicated example where we have to involve calculations of area, right? It comes back to maximum or minimum, right? This is where these come in, sort of. Set up an equation with the given information. In fact, I would just not have this as a separate point. Set up an equation with the given information and write a suitable formula for whatever we maximize or minimize. I would say set up an equation which is suitable to maximize or minimize. These are like the same thing, like writing the formula or setting up the equation, same thing, right? So it's just setting up an equation that is suitable to maximize or minimize. Then substitute the first equation into the second equation. Okay, you see, this is not always, you don't always have to do this, right? This is just representing one in terms of the other. It's not always the case, okay? But the fact remains is if you want to find maximum or minimum, you need to derive it and equate it to 0. Okay, so that's exactly what we're going to do here. And let's read the question. Hopefully it will make more sense. How much time do we have? A decent amount of time. Okay. Let's have a look at this, right? So it says O is the center of a semicircle passing through A, B, C, D. The radius of the semicircle is x minus x squared units, for x being between 0 and 1, okay, not including 0 or 1. And triangle AOB is a right-angled triangle at O. Okay, so we have the semicircle. Okay, and within the semicircle, we have another triangle, right? That's sort of represented by this. This is like a sector, right? So this triangle is here. Also, the triangle is drawn as well as the entire sector. Okay. And they're saying that AOB is a right angle. Okay, so that's 90 degrees. So let's try and make sure that all the information in the question is in the diagram so that that's easier. It's easier for us to work with that. So the first thing is the radius, right? Remember, this is the semicircle with center O. And its radius would be to the circumference of this value. It's x minus x squared, and whatever the unit is. And so too is AO. This is also x minus x squared. Okay, so these radii have the length of x minus x squared units. Okay, let's see what the question wants. 10.2.1, show that the area of the shaded part is given by pi minus 2 over 4, x to the 4 minus 2x cubed plus x squared. Okay, complicated question, right? So this 5-mark question, sometimes they can just say that, determine the value of x. They just can ask the second question, and then the question will be out of 9 marks. But here they've separated into 2 different questions. Now, this is where the skill of trying to develop, this is the difficult part, okay? Trying to express or trying to create a formula that represents what they want the maximum of. So they want us to determine the maximum, which will determine the shaded area will be maximum, the maximum shaded area. Okay, the value for x for which the shaded area would be a maximum. Okay, so in that case, you would have to get a formula for the shaded area so that you can derive it and equate it to 0, and to give you that x value that would create the maximum shaded area. Okay, so that's why we have to try and formulate an equation that would represent the shaded area. That's why in the first question, they say, show that the area of the shaded part can be represented by this formula. Okay, we want to get an expression to represent the area of the shaded region so that we can derive that equation to find the maximum shaded area. Okay, I hope that makes sense. So we know from calculus, right, that if you want to find the maximum of anything, we need to derive it and equate it to 0. So therefore, in order to derive, we need an equation, right? We need a suitable equation for whatever it is we want to find the maximum of. So that's our first step. Formulate an equation, a suitable equation, okay, for whatever it is that we want to find the maximum of. In this case, it's a maximum area. In other questions, it might be the maximum or minimum cost. Okay, in other questions, it might be something else. Okay, but whatever it is that we want to find the maximum or minimum of, we need to formulate a suitable equation so that we may derive it and equate it to 0 in order to find the maximum. Okay, I hope that that's making sense. Okay, and that's why you know that the shaded area can be represented by that, or calculate the or just write an expression for the shaded area. Now, this question, the way they've put it is really nice because they've given it in 2 parts. The first one is calculate the area of the shaded region. And then the second one is find the maximum area of the shaded region, or find the x value for which the area would be maximum. Okay. Now, again, like I said, they could have separated, they could have written this as 1 question, just the number 2, and then it could have been out of 9 marks. Okay. The reason why this is nice is because, okay, I'll show you later on. Let's look at the first part, but I'll tell you later on why it's actually nice that they separated it into 2 parts. Okay, so let's have a look at this. Okay, show that the area of the shaded region is given by this value. Now, like I said, the key is to try and get an expression in terms of the unknown for the shaded area. Okay. Now, the shaded area is a segment of a circle. This is what we refer to as a segment. This is the shaded area. Right, it's the area that has the dotted lines. This is the shaded area. Now, there's no specific formula, right, that's constant for that type of shape. Okay, so we have to work with what we have. So firstly, we have a semicircle, which we know the formula of, right? A full circle is pi r squared. So the semicircle is half pi r squared, right? It's half of it, okay? Another thing we can possibly work with is this part, and this you should remember actually, maybe if you don't remember, it's from grade 8. This little sector of the circle, that actually kind of has a set formula, okay? We'll get to that in a bit. So we have that sector, so semicircle, that sector, as well as this triangle, which we could work with. So it's broken up into different shapes. Now, the way that we're actually going to do it is, if we look at this sector, now this sector is made up of this entire region, including the shaded area, as well as this extra triangle. But first, let us try and formulate an area for that sector. Now, you should be remembering from grade 8 that in order to calculate an area of a sector, we have to work with the angle if it's given. The way we work with it, this is a 90-degree angle, we can calculate how much of the circle is the sector, okay, using that angle. The way we do it is we take that angle, that's of course a 90-degree angle, we divide it by the total possible angles inside of a circle, which is 360, and that gives you 1/4. So that tells us that a sector created with a 90-degree angle is always going to be a quarter of the circle. So this yellow entire shaded region is a quarter of the circle. So the area of the sector would be equal to a quarter times pi r squared, because remember the whole circle is pi r squared, that's area of a circle, and a quarter of the circle is going to be a quarter times pi r squared. So we can get the angle, sorry, we can get the area of this entire thing, this entire sector. But now we don't really want the area of this entire sector, okay? We just want the area of which part? The sector minus this triangle. We don't want the area of the triangle. So we can get the area of this entire sector, but we need to subtract the area of that triangle. Okay, and that gives us that. So this is actually, we can set it up, we can write out an equation, area of, we'll call this is a segment. Okay, so the segment is the shaded region. Okay, if you do, of course you do Euclidean geometry, you remember that we discussed segment. Okay, a segment is basically any what you call these things? What you call this? Any line. Okay, any line thrown from one end of the circumference to another end, I forget what they call it, for some reason, a chord. Okay, any chord in a circle would separate that chord into two segments, that segment and then the other segment. So that's why that's referred to as a segment. Okay, and area of the segment, which is what we want, area of the shaded. Actually, let's not use segment, let's use shaded. Area of the shaded, because that's what they want us to calculate. Area of the shaded can be represented by, right, now area of the sector, okay, which is this entire thing. This is what we refer to as a sector. Okay, it's this entire thing minus this triangle. Area of the sector minus area of triangle. And that's essentially the most important step of formulating this equation. It seems a bit complicated, but if you break it down into steps, okay, it's much easier, and you'll see that you'll sort of get used to it if you practice a lot of these questions, and that's what I would recommend. Sorry, just give me 1 second. Sorry, someone was trying to join the lesson and they couldn't. Okay, so yes, this is the most important first step, right? This is the important first step. Separating, like understanding how are we going to calculate that area. Okay, like I said, it's complicated, but if you break it down into simple steps, it can, and when you practice more, you have to practice, right? So all of your sections, like my number one advice in this subject is to practice. That's the number one for any topic. You ask me, what's the best advice? How can I improve on this? Practice. right? Start off, watch the lessons, understand your basics. Once you understand the basics in most of your sections, the basics are really easy to understand most of the time. Like if you do Euclidean geometry, okay, each individual circle, if I just told you understand that circle and how it works, you most likely can tell me, yes, I understand how that circle works. But like it's when you put 500 circles together, that's when it can get complicated. But that comes better with practice. So the same thing is with application of calculus. Like you'll see that maybe some of these things, right, it requires a bit of extra thinking, a bit of thinking outside the box. Like formulating this equation might not be easy, but like I said, the more you practice, the more examples you expose yourself to, right? Firstly, the higher the odds something in your exam is going to come out that you've already done, okay? Because it's not like there's 700 million different types of questions they can ask. There's a few different types of questions they can ask. So the more you practice, the higher the chance that something you've come across is going to actually come up, and then you'll know how to do it. And even if you didn't specifically think of, oh, how do I do this? But now you're seeing it in this lecture, and I'm showing you that's how you do it. And there's a chance that this could come out in the exam. So you're going to follow a similar procedure. Okay. So yes, that's where practice can get you. So like I said, area of the shaded can be calculated by taking this big area and minusing this area of the triangle. Okay. So that's exactly what we're going to do. And the area of the sector is calculated like this. A quarter pi r squared. How do we know it's exactly a quarter? Because of this angle 90 degrees, we can actually do this calculation. This is on grade 8, calculating the area of a sector. We can take the angle that sector is made up with and divide it by the total angles inside of a circle. And that would give you the portion of the circle it is. It's 1/4, sometimes 1/3 and whatever. But in this case, it's a quarter. Okay. Sorry, let me just put this to chart. Cool, right? So that's how we're going to get area of the shaded. So the shaded area is equal to area of the sector. We're going to do this one more time. Area of sector minus area of triangle. Okay. And now we're going to write out equations for each one. So the area of the sector, we said is going to be quarter pi r squared. But now we have a value for r. It's x minus x squared. X minus x squared. So we're going to substitute. You're always going to get it in terms of an unknown. Okay, always. There's going to be some unknown inside of your formula, and that's okay. All right. It says here, it's an expression of the area. It's not an exact area. It's a formula that will help you calculate the area according to what value of x you're going to substitute. Okay, so that's why we subbing in x here. So the area of the sector is pi r squared, but we have a value, pi r squared. We have a value for r, so we substitute it. Now area of the circle, area of the triangle. This is a perpendicular triangle. It's a 90-degree triangle. So we can just use half base times perpendicular height. So it's going to be this, guys, half. Let's just write this. It's going to be a quarter pi r squared minus half base times the perpendicular height. Okay, it is a 90-degree perpendicular triangle. So we can opt to use this as the base. That's fine. And use this as the base. And this is the perpendicular height is always perpendicular to the base. And we know that that can be used as perpendicular height because it's perpendicular to the base. So perpendicular height. So essentially the base and the perpendicular height are the same. So we're going to have half times the base times the perpendicular height, okay, which are essentially the two same things. And what I'm going to do is, because these are the same things, I'm going to put a square on the outside so that I know that there's two of them, okay? So x minus x squared squared, and then yeah, x minus x squared squared. So this whole time, this is the very most important first step, that if you can get this, you essentially can get the rest of the questions, right? This would arguably be the most difficult part, okay? To get an expression for the shaded area, whatever you want to find the maximum or minimum of, to formulate an equation that basically just gives you that without getting the maximum, whatever you want to calculate the maximum of, let's just say in this case, shaded area, when you calculate what's the maximum shaded area, you need to formulate an equation that gives you the maximum area, okay? In terms of substituting a particular variable, in this case, it's x, right? So this is this. Now, all we have to do is, so again, what's nice is when the question is always nice, when they say prove that this is this. So like if you remember in functions, sometimes parabola, they'll say prove that A is 3 and B is 6 and C is 7. So when you get your answer, you got 3x squared plus 6x plus 7. And you can see, oh, that's right. When they say prove that it's equal to that, that's a nice question, because then it's basically they give you the answers. You just need to prove that that's the answer. And when you get your answer, you're certain that it's correct because you've proven it to what they said it is. So here they want us to prove that it's this. Okay, so this is correct. I'll tell you it's correct, right? That's 100% correct. So now we just need to get this to that. Okay, that's why this is the main part done. It's the first expression of the shaded area. But now we just need to simplify to that. Okay, it's just simplification. So if you stuck, right, if you cannot, algebraic simplification can get tricky and confusing sometimes. I understand, like simplifying this with all the variables and the squared and everything. And oh my days to get that. It's like, geez, that's so much work and blah, blah, blah. If you do get stuck, try to simplify this as far as possible. And then if you can't get this exactly, okay, if you didn't get that in your simplification, simplify it as far as possible, as far as you can, and then just write this on the next step, because you know it needs to get to that. Provided that all your first steps are correct, right, you need to get to that. So that's just like a little cheat, okay? Simplify this as far as possible, and then just write that on the next step. But now what I'm going to do is simplify it. So I can take a common factor, right, of x minus x squared squared, because it's common in both terms. And I'm going to take it as a common factor, x minus x squared squared, and I'm left with a quarter pi minus a half. Okay, now if you remember from trigonometry, when you're doing trigonometric equations and you're trying to prove left hand side is equal to right hand side and so on, we always use the answer as a guide. Okay, so I'll give you an example. Like we had 10x, so I'm just going to make it simple, minus 2. Okay, let's just do like, we have like, okay, 10x minus sin x over 2 sine squared x plus 1 is equal to cos x plus 10x, whatever, right? Just say you have to do this proof, and then they say left hand side is equal to right hand side. Okay, when you always simplify the more complicated side, and then you always like, you look at your answer for a reference, you look at it as a guide, like, okay, how can I simplify this? Oh, there's a 10 here, so how can I get a 10 from the left hand side, right? That's what I'm trying to get at. You always look at your answer as a guide. So that's exactly what you should do for this, like look at your answer as a guide. So you can see that your answer has this, and it has that. It has a bracket with pi, and it has a bracket that's like x, right? Simplified out like a not a trinomial, but with 4. Okay, a polynomial. So as you can see, we already kind of have these two brackets, right? I have this x minus x squared squared, and then I have this a quarter pi minus a half. So you're like, oh, okay, maybe that this one with pi gives us that, and then this one with that gives us that. That kind of like looks like it makes sense. So that's how you can use your answer as a guide, right? So that's exactly what they did. So I'm going to swap the order. So I'm going to write this one first now, because they have it first. And actually what they did here is they did LCD, because this is a subtraction of fractions. When you, in order to add or subtract fractions, you always have to do LCD. So they did LCD. And if I do LCD, my lowest common denominator would be 4. Okay. And if we rewrite this as pi over 4, because 1 over 4 pi is the same as pi over 4, the LCD is 4. So to go from 4 to 4, I multiply by 1. So those would remain the same. But to go from 2 to 4, I have to multiply by 2. So 1 multiplies by 2 as well. So this essentially becomes pi minus 2 over 4. And I just wrote this here. And I'm going to write that there. Okay. Pi minus 2 over 4. And that's exactly what they get. Right. Again, if you didn't even like think of LCD, if I was you, I'd see literally, if I see pi here and pi there, just copy it directly. Right. Even if you don't know how to get it, it's just something. Okay. Pi minus 2 over 4, and that's exactly what they get. And now they got this, which is basically expanding this, x minus x squared, right? This is basically, we're going to do FOIL here, right? Or you can use the shortcut, because this is a binomial squared. Okay, so I'm not going to even bother. I know that when I FOIL this, I do first outer inner last, I'm going to get exactly that. So you don't even have to fold, you can just copy it down if you're certain that your previous steps are all correct. So this is going to become pi minus 2 over 4, and this becomes x to the power of 4 minus 2x cubed plus x squared. Okay, if you want, you can FOIL it out yourself, FOIL this out, and you'll see you get this exact thing when simplified and rearranged. Okay, so I know that took long and I'm taking a long time to explain this, but I really want you guys to understand this concept, right? Because if you understand this question, it's really good, right? And it's a good guide to how to answer the other type of questions. Okay, so yes, okay, so that's done. We have proven 10.2.1. 10.2.1 show that the area of the shaded part is that. We've shown it. Because we know how to calculate the area of the shaded. We took area of that sector minus area of the triangle. We created formulas for each area, substituted in the correct radius for each, or base height, whatever, and then simplified it to get what that expression was. Okay, now let's look at 10.2.2. What does 10.2.2 says? It says determine the value, the x value for which the shaded area will be maximum. Now, remember, maximum. What do we know about maximum? Before we even think anything, like, oh, maximum, derive and equate to 0. Want to find maximum shaded area? The formula for shaded area, derive it and equate it to 0. So now I know the area for shaded area. It's this guy. It's, let's just say, shaded area. Okay, let's do this. Let's say shaded area is equal to that formula. So pi minus 2 over 4. And we have x to the 4 minus 2x cubed plus x squared. Okay, that's the formula for shaded area. Since we want to find maximum shaded area, we need to derive our shaded area formula. So shaded area prime, that represents its derivative, and equate to 0. We need to derive the formula for shaded area and equate to 0. That gives us maximum. Okay, that gives us maximum. So let us derive the shaded area equation. Let us. Okay, it's fine. Now, in order to derive this, okay, if we have a look at it, it's quite complicated. I want to rewrite it because I need it to be neat, otherwise I won't be able to work. Copy this. There's the equation. We need to derive it and equate it to 0. Now, you know that one of your differentiation rules tells you, okay, we've learned it in calculus, the start of this section. It tells us that in order to derive, if we want to derive, we need to differentiate first, okay? Then one of the rules of differentiation says that we cannot have multiplication, okay? So for example, pi minus 4, okay? That whole thing multiplied by x4 minus 2x cubed plus x squared. That's true. However, if we open this up, okay, it's going to be a really complicated term in order to derive. It's going to be a really complicated term that we need to derive. So what we can do, this is a little bit of a trick, and it is tricky in this question, I'll be honest. All right, so even if you got up to here, get your 5 marks, you can be happy with that, okay? But what you can do here, okay, and how you can understand it is, this is an equation for the shaded area represented in terms of x. It's an equation for the shaded area represented in terms of x, okay? So we need to derive an equation with x and equate it to 0, solve for x, that gives us the x value that the shaded region would be a maximum. So if we look at these two, this is like a coefficient, right? It's basically going to multiply, it's like a constant. And when we multiply it, it's just going to become a coefficient of each one. But the fact remains it is a constant. It doesn't have an x. In this term, there's no x. So what we can just do is simply, we can derive this equation, which has everything in terms of x. And when you get that x value, okay, when you derive this and equate it to 0 and you get that specific x value, you substitute it in here and you'd have to multiply that answer by the constant, and that would give you your maximum shaded area. So we don't actually have to multiply this out. We can basically just ignore it to find the shaded region. We can derive x, okay? We can derive the shaded area formula by just deriving the terms with x, okay? So this becomes 4x cubed minus 6x squared plus 2x. That becomes the derived formula. Again, we're not worrying about this constant. Okay, so derive it and now we equate it to 0. So there I've done it. I've derived it and I've equated it to 0. Now we need to solve for x so we can factorize. So what we can do is we don't have to do the cubic factorization like B method, because we can actually just take a common factor of at least one x in each term, as well as if we look at the coefficients, we can take out 2 because 2 can go into all of them. 2x is a common factor. Then we're left with 2x squared minus 3x plus 2 still equal to 0. Now in the brackets, we have a trinomial, so we can do some trinomial factorization. And when we do trinomial factorization, we get, let me see my answers. Um, 2x minus 1 and x minus 1. 2x minus 1 and x minus 1. Let's do this. Okay, now we have 3 factors equated to 0. So we can either have 2x is equal to 0, or x minus 1 is equal to 0, or x minus 1 is equal to 0. So we have either x is equal to 0, or x is equal to 1 over 2, or x is equal to, sorry, 1, not 0. X minus 1 is equal to 0. So or x is equal to 1. These are our 3 options for x. That's going to give us a maximum value for the area. So how do we choose? So of course, firstly, it cannot be 0. Okay. X cannot be 0 because if it's 0, okay, that makes 0 minus 0 squared, that's 0. So it's telling us that the distance of AO is 0, and you can never have distance as 0, especially if you want to have maximum, right? How can a distance of 0 give you a maximum? That's not possible. So 0 is out of the question. Now it's between half and 1. There was a certain criteria in the question that said that x is between 0 and 1 is not included. So it's every value between 0 and 1 except 0 and 1. So therefore 1 is out as well. So actually our correct answer here is a half. So yeah, our correct answer is a half. So the x value for which the shaded area would be a maximum is a half. Are there any units? No, because no specific units, because they just use the word units. And the x value would be a half. A half as x would result in the maximum shaded area. Okay. So yeah.